The learning objective of this lesson is to apply Newton's third law quantitatively. And if we remember quantitatively, Newton's third law tells us that the force applied by A to B is equal to the force that B applies to A in the opposite direction. These are our action-reaction force pairs. So the type of situations we're going to be looking at are these very simplistic block-type situations with an applied force. So to do these, we need to combine Newton's third law with Newton's second law, and we have to treat the blocks in some parts of this method as a system. Now, the system is all the blocks interacting as one, and we are going to ignore friction and other force pairs, such as those in the vertical direction. So between blocks S and T, an interaction is going on. S is pushing on T as a result of the applied force, and T is pushing back on S as a reaction force. So what we want to do in this question is determine the magnitude of the action-reaction force pair at that point. So diagrammatically, you can see S is pushing on T and T is pushing back on S. So what we're going to do is imagine these blocks as a single system. To do that, we just add their masses together, so we end up with a 9 kilogram mass. Now we can apply this to Newton's second law, and we're going to have an applied force of 45 divided by 9 to give us that acceleration of 5 meters per second per second. So now we can say that that system is accelerating at 5 meters per second. And what that means is each block is accelerating at 5 meters per second per second. So we can now use that information to figure out information about block S here, the 4 kilogram block. So we're going to isolate it. So we're just going to imagine it's the only block in this system, but obviously the other forces that the other blocks are applying still exist. So net force is equal to the mass times the acceleration. Well, we know it's mass and we know it's acceleration, so it's going to have a net force of 20 newtons. So we can now take this and apply it to the net force formula, which is it has two forces applied to it, the applied force and the force that T applies to S. So we add the two together, but we're going to rearrange this to make the force that T applies to S as the subject, and we end up with the net force minus the applied force. 20 minus 45 gives us negative 25 newtons. You probably could have done that last part in your head, but that's it laid out in the correct mathematical way. So because the force that T applies to S is negative 25, well, it goes without saying that according to Newton's third law, the force that S applies to T is equal to 25 newtons. Right, that's a really simplistic scenario, and we'll do a fair few of those in your upcoming quiz. But we are going to step it up a notch with a slightly more challenging one, which has 3 blocks in it and multiple applied forces here. I've written one as an applied force and one as a friction force, but we can just consider them as just applied forces. But for notation purposes, we've labeled them differently. So the net force in this case is the first thing we got to figure out. What is the actual net force being applied to this system? So we have 250 plus minus 50 gives us an overall net force of 100 newtons. So now we want to find out what is going to be the acceleration of this system. So F equals ma, we've got a net force of 100, a mass of 50, nice simple math here. Acceleration is 2 meters per second per second. So I'm going to follow this whole system again now that I did in the previous example, and I'm going to isolate each one. So the first one I'm going to look at is X. So the net force on X is equal to 16 kilograms times its acceleration, which is 2. So it has a net force of 32. So I'm going to jump to that net force formula again, and I've got an applied force and the force that Y is applying to X. Those are the two forces being applied to X. So those are the net forces. Rearranging it to make the force that Y applies to X as the subject, and I end up with 32 minus 250. So the force that Y is applying to X is minus 218 newtons. Therefore, the force that X is applying to Y is 218 newtons. Now I'm going to jump to our friend the Y block, the green guy. So he will have a net force that is equal to 20 kilograms times 2 meters per second, which gives us 40 newtons. I can now do that same thing again where I use the net force formula of it has two forces being applied to it, the force that X is applying to it and the force that Z is applying to it. So we end up rearranging that to find the force that Z is applying to Y, and we end up with 40 minus 218 gives us minus 178 newtons. Therefore, the force that Y is applying to Z equals 178 newtons. All right, I know that was a whole lot of mouthful. I went through that very quickly, and you can use that as a reference point for going through these. But as you can see, it was a very simple methodology that I used, and I just applied Newton's second law and this idea